So just a little bit about Meta to begin with. We are a company that is based in Silicon Valley. We actually work at a ranch house on top of a mountain. It's surrounded by wild turkeys and mountain lions and deer. As a matter of fact, I was just telling someone that I walked out of, I work in a car barn, and I walked out of the car barn the other day and like a deer ran right in front of me, like 10 feet in front of me. So it was quite an early wake-up call. But we're about 70 people, a little more than 70 people now actually. And about 20% of them are PhDs. So you literally cannot have a conversation in the ranch house that we work at without having a PhD in that conversation. And it's usually something around mathematics. So there's a lot of math that's going on. We're fixing some really big problems. And that's kind of the exciting thing about working at Meta is that I've worked at a lot of companies where we solve, one or two or three big problems, or at least we felt they were big problems. I mean, we weren't saving the world, so they weren't that big. But with Meta, we're solving really, really big problems. I swear, every day I hear about 10, 13 different things that we're solving. Everything from how people interact with digital content to the sensors to the optics. It's unbelievable the kind of conversations that are occurring at Meta. So if you're interested, we're always hiring. So let me know, or go to our website. Even better. And we've been shipping a product since last September, October. It's called the Meta 1. It is a developer kit, and we let people interact with, we basically build the hardware and the SDK, and then third parties usually build the applications, and I'll show you some of the applications that people have built. Some of the people that are on our, sorry, we announced that, so financially we were a Kickstarter campaign. We doubled the amount of money that we were trying to raise. We then became a Y Combinator company. We became the most funded company to come out of YC. And we also announced $23 million in funding last January. So that's kind of where so we have money. If you're looking for a job and you still want to have a job that pays, we can pay you. And so Meryl Grivitz is the CEO of our company. He really had this vision. He went to Columbia University, and while he was there, he was at a bar with a friend, and the friend got a phone call, and he felt excluded from the conversation. The guy was like, chuckling and giggling, but all he was seeing was the back of the phone. And so he's like, it would really be cool if this conversation was something that we could collaborate around and we could all look at. And that's sort of the brainchild that he had around building Meta. And so then he also worked in Professor Steve Feiner's lab. He's in Columbia University as well. Some other notable people here, Steve Mann, Professor Steve Mann, who's an MIT guy, but now he's at the University of Toronto. He's essentially the father of wearable computing. I think he told me that he built the first AR device for himself when he was 12, made out of like vacuum cleaner tubes and all kinds of different things, so that was really exciting. Jace Hansen, has anyone seen Iron Man by chance? Okay, so Iron Man, Ender's Game, all that. The interfaces that you see, those are all done by Jace Hansen. And Jace is our creative director as well. Soren is my boss. He's one of those, another intelligentsias. Stefano Baldassi, he's another PhD. He does a lot of user perception and user experience with Meta, a lot of research. And then we have a couple of academic partnerships. These are just to name a few. We actually have a lot more than this. But a couple of no-name schools like Columbia University, University of Toronto, Stanford University. I don't know if you've ever heard about them, but they're scattered around North America. And then this is what it looks like. So this is the Meta 1. And you'll notice that there's a depth sensor, and then there's an RGB camera, and there's a microphone here. It's a see-through display, stereoscopic display, 960 by 540. It also houses an IMU here on the side, so it knows your location of your head, has the accelerator and the gyroscope and so forth. And then it has Dolby 3D sound, and that logo might look similar to some people. Can anyone tell me?
MIT.
Yeah, there we go. All right. You'll win my business cards later. So why are we focused on AR? And I told you a little bit of story about Meron, but what really solidified it for me is about 4 months ago we were doing a workshop. We do these workshops all around the world. We're actually going to be doing one here in Boston in September, like the 24th and 25th of September, where in 2 days we teach people how to work with our SDK and build an application and interact and things like that. And so we did it at this place where they have an after-school program. And so we said to the kids after the second day, hey, would you like to come down and see some of the apps that were built over the 2 days? And they were very excited. There were probably about 25 or 30 of them. And we brought them down, and this little boy, hopefully you can hear it, but this little boy really solidified it for me. excited to get started. And what was really great about this is we really didn't have to explain to him what to do. He just jumped in there and started interacting with digital content. And so he was super excited. It was really great to see that because we really think that this world is inevitable. We think that these devices that we're carrying around, like I have 2 boys, and I say to my son, I say, you know, can you give me my mobile phone? He's like, well, isn't it just your phone? And I'm like, well, yeah, I guess it is. Considering I grew up with a phone on a wall that, you know, if you wanted privacy, you went around the corner. And it had a contact list next to it, of course, and that was a piece of paper that had all my aunts and uncles' phone numbers on it. And I think about it now, I'm like, well, wait a second, yeah, I guess you're right, that is just a phone. So, you know, our goal is to think about, you know, how do we actually get to a point where we can make it really easy for users to interact with digital content and with computers and not have to learn things like, well, how to type, for example. Why should you have to learn that, right? You should just be able to do things that we've done since the beginning of human beings existed, which is grab things and poke at things and things of that nature. So we let you do things like grab, poke, pinch, rotate, one-handed and two-handed rotate. You can resize things. You can do different things like that with our SDK. And part of the reason why we do this is because we know that there's some really big problems out there. I mean, if you ever watch Vice, you realize we're already screwed. And you want to get depressed, it's a great show to watch. But you know, we've got some really complex issues we want to solve, and you know, the way we learn right now is essentially in 2D. We read it out of a book or something like that, and we want to learn in 3D. 3D is a great way of learning because we live in 3D, and if you could have explained to me chemistry in 3D at the time, that would have been awesome. And let me interact with, you know, the compounds that I'm putting together, as opposed to me trying to extrapolate out of a book how that would actually look. And so we think that there's some really complex subjects out there and some complex subjects that we can help sort of help people learn and learn faster. And what we've already seen is that people who are using AR devices are not only learning faster, but they're learning more efficiently. And there was a study that was done actually by Boeing, where they had a bunch of guys working on an F-35, and they're using heads-up augmented reality glasses, and they've been able to find out that fewer mistakes are being made, and they're being able to complete these aircraft much faster. I think they cut the time down by 70%, which is a huge amount of time if you think about how much it costs to make one of these airplanes. And the other thing we think about is, I think about this a lot, like, why do I have a desk? The only reason why I have a desk today is a place to put my monitor. Why? Why am I limited? Why are we all limited right now to this rectangular screen? You're all looking at this rectangular screen, I hope, and there's no reason why we shouldn't be able to interact with that as being 3D content, right? So we think that we can go beyond that. We're seeing a lot of companies come to us because they're the ones that are saying, look, we don't want to make our people redundant, but we want to increase our output. We want to optimize them and make them better and work faster. Those are the results that Boeing had seen, and a lot of companies are doing it across the line. And I'll talk a little bit about some of those applications as well. And so what we see is usually 3 different types of use cases. One is presentation and remote collaboration. So that is the idea where you know, we have somebody who's in, say, in Uganda, and we have somebody here in Boston, and they're trying to perform a surgery there, and they can actually guide them here by using the Meta 1 or the Meta glasses, that they'll be able to actually guide them as far as the surgery goes, or whatever they're working on, whether it's a mechanic or something like that. And I'll show you a use case about that. Another is information panels, being able to present information for people to see in a sort of in a heads-up display. And then 3D creation and visualization, and I'll show you something like that as well. So right now, does anybody know what the 4th largest cause of death is in a year in the United States? Anybody know? VR. That's the number 1 cause of sickness, nausea. No, it's medical error. Medical error. More people die of medical error in a year than they do of car accidents, breast cancer, and AIDS combined, which is frightening, right? And if you look, a lot of the time they're being trained either on the job, or they're being trained in a situation where they're in a classroom. Now, what I find incredibly, here's this doctor explaining about this infant, but what I find incredibly shocking about this one picture is that look at the students. How are they all sitting? They're sitting there with their hands crossed at a table. Now, do you think you learn better with your hands crossed at a table, or actually interacting with the content that you want to have, right? And so what you start to see is the DoD came out with a study, or sorry, there was a study that came out, and it said that we were losing about 100,000 people a year and about $80 billion through medical error. And then a few years later, the DoD said, well, look, if we train our people through simulation, then we can actually lower the fatality rate from 31.5% to 4.5%. That's a lot of lives that we could save, right? And so you start to see a lot of medical simulation plans pop up, and they cost very much. They're very expensive. And so, but the interesting thing is all of the mannequins are fit white men. Not everyone is a fit white man, right? And so, these mannequins cost upward of $250,000 to $500,000. So you can't have very many of them. So in places like Stanford University and places like that, you can have them because they have the money to do that. But if you look at a rural hospital, you cannot have that. You can't afford it, right? So you start to see things like these virtual reality simulation pop up. The interesting thing about this is it's a completely fake scene that you see. That everything around it is somewhat fake. Or you have a classroom, for example, in the lower left-hand corner. Or we had a company that came through that does endoscopic procedures. And basically right now when you do this, you're looking at the feed on a screen across the room. Well, they said we don't want to do that anymore. So what they did was they overlaid now on the patient where they should be making the incisions. And then on the right-hand side, they have a panel that says, here's the camera feed, and so you can see what's going on with the camera, and here's the vital signs of the patient, and on the left-hand side is the next steps in the operation, right? So now they're training people by actually letting them look at the patient the entire time, and their head maybe moves an inch either way, but they're always being focused on the patient, which is really exciting. And so last year at TechCrunch in San Francisco, which was, I guess, September or something like that, these two doctors, they're a company called, they're doctor, one's at Stanford, the other one's at San Francisco General, but they created a company called Simex. And Simex makes an augmented reality application, and the application now lets you have any type of patient. So you can have, it doesn't matter, you can have women, you can have men, it doesn't matter what their age, it doesn't matter their ethnicity, it doesn't matter at all, and they can have a variety of different ailments. So you can have rashes now, you can have seizures. Right now he's given her an injection to soothe her from a seizure that she's having, but you can also do things like ultrasounds, and you can listen to their heart rate and a variety of different things, all through looking through these Meta glasses. Now where you see black up here at the top, they actually see through. And they're both, even though you don't see her, that's actually what they're looking at. They're both seeing her down below. So you can see how they're interacting. And so now you can have a medical simulation room anywhere by simply putting a fiducial marker down, which looks like a little QR code, on an empty bed that you may have in a real trauma center, right? Or you can put it on this podium, or that table, or the chair, or on the floor. It doesn't matter. You can automatically now create a medical simulation plant for, or place, for dollars as opposed to millions and millions of dollars. And those patients can be different ethnicities, they can be pregnant women, they can be, here's a good example of the markers, right? So you have, and here's two examples. Here you have 3D visualization, you have this toddler, and you have the fiducial marker here, and then you have another marker here, and you have a panel. So this is the panel that you would see of their vital signs, for example, right? And then down below here you have, obviously a variety of different, I guess this is a no carb diet, full carb diet. So that's one example, right? Another example that we have is, has anyone here not seen, I don't want to call anyone out, has everyone here seen Star Wars? Okay, so in Star Wars you may remember when Princess Leia says, help me Obi-Wan Kenobi, you're my only hope, right? Well, that was done with a CGI effect, right? So I'm going to show you an example of that, and then I'm going to show you what somebody did in a day and a half at one of our workshops. Sorry for how loud that was. But what they're using here is a different type of tracking that we have. It's called canvas tracking, and basically what it does is not only do they have the 3D visualization, they're able to track it on this rectangular box. And as they move the box around, the image moves around with it, right? So they've actually, in a day and a half, been able to create this model. And so they do things like 3D conference calling. So if you want to have a conference call with someone and they're in another location, you can actually have that done in 3D, which I think is really amazing. We had another company that came from South Africa, and in South Africa they have these CT scanners that are being shipped all over the continent. And the problem is that when they ship it to certain places, the staff isn't as well trained, and so something goes amiss with it. They don't know what to do, and so then somebody from South Africa has to fly up to this place, and it costs thousands of dollars, and it turns out somebody flipped a switch or something small had happened, right? So they just spent thousands of dollars to find out that somebody hit an emergency switch by accident. And so now what they're able to do is have people actually go through the process themselves and have, okay, this is actually where you're supposed to insert the screwdriver, and this is how you do it, this is what the real machine looks like, this is what the image looks like, here's how you go through the step process. Or you can have somebody on the other end guide you through that process, for example, right? So, so now they are able to save thousands and thousands, hundreds of thousands of dollars a year by not having to ship people all over the continent. Another one is a company that does logistics. They work for companies like DHL and so forth, and what they're able to do is let you choose whatever the right item is that you want to put into a bin, into the right bin. So if you can shave a second off every time that you ship an item, you can imagine how much money that is, right? That's a lot of money in savings that they're having, right? So you can actually say, for example, if they reach out for a green dot, they get the green dot. I mean, they get the right item. If they get a red dot, they get the wrong item, so they know which item to choose and which bin to put it in. So really, we've seen applications sort of run across the gamut, from games to medicine to logistics. I mean, you name it. We have lots and lots of companies coming to us because they're trying again to figure out how do they optimize their people. And so really, it's unbelievable. Like, I think, you know, to say that we're at the tip of the iceberg is actually deeper than we really are. I don't even think we're there yet. I think the possibilities that we have right now with augmented reality and sort of visualizing and certainly, you know, we want to be at the forefront of that and lead this space is really exciting, and it's exciting to see what people can develop out there. So we're really excited about doing things like that. So we're actually Unite is we integrate with Unity. So you build on the Unity engine that integrates with our SDK. And so Unite is having a show here in Boston on, I think it's September 21st, 22nd, 23rd, somewhere in there. And then on the 24th and 25th, we're actually running a workshop here. Not at this specific place, but here in I think on Hampshire or something like that. And so if you'd like to come, there's some cards in there. We'd love to have you and help you build the apps that you want to build. And that's really it. So thanks so much for your time. I really appreciate it, and I can answer any questions you have.